So I was waiting for 5 minutes and then we start. Yeah. So hi everyone, welcome to another session for Stella. So Stella has partnered with Hadao and is doing a 1 month Stella bootcamp where we'll be learning about Stella, and at the end of the month we'll be building great projects, and hopefully we'll have some of us attending the residency that is organized by Hadao in August, hopefully. Yeah. So without further ado, I'd like to welcome the newcomers, and I'd like to welcome our tutor Ayomide to take us through today's session. Yeah.
Okay. Hi, everyone. Happy to have everyone here on board. And we would basically continue from where we stopped last class, and we just continue, basically. Let me quickly turn on my camera so we can have that. Oh, the host stopped it. Okay. IJ, could you look into that? But without wasting our time, I think we should just dive in. I would also try to share my screen so we can proceed from where we stopped last class. I noticed I can't share my screen too.
I have
Could you
given you
also check?
access. Yeah, you can try again.
Okay, okay, I can't start the video though. But that's fine, that's fine. We just continue.
Okay.
Okay, so in fact, before I go to what we have today, I always like if there's any of the participants who is willing to give us a heads up based on what we discussed from last class. So, who is willing to give us a heads up, give us like a refresher, a reminder of what we discussed from last class? Anyone? You can just use the raise hand button and you'll be brought to the stage. Anyone? Or should I just mention names and then we can. Okay, let's hear from Tosin. Yeah, Tosin. Yeah, Tosin.
Okay, good afternoon, everyone. Good afternoon,
Good
Yamide.
afternoon.
Yeah,
Yeah.
what I actually remembered from last class was we discussed about data type, and we talked about the unsigned and the signed integer. That's the I32, U32, I64, U64. We talked about the function, like function that we could use to like we made an illustration that function is just like the way we have refrigerator in our home, the way we have microwave in our home, that they have a particular function they do. They take in input and they um what's it called? Provide an output, stuff like that. And we talk about the main function of um what's it called? Main function
Trust.
that brings in a main function of trust, that where the whole stuff is being processed. I think that is everything I could remember.
Excellent. You've done excellently well. You've done excellently well. Thank you so much. I appreciate that you remember the illustration I used when I was talking about what a function basically is. Thank you. Let's also hear from Stephanie. Stephanie, please.
Hello, can you hear me?
Yeah, we can hear you.
So yesterday we spoke about mutability. You said that Ross is immutable, has an immutable state in such a way that anything that is added cannot be changed. So in such a way, when you want to change like your state, you have to put the mute keyword, like e.g. let's mute x equals to 5. Do you understand? So
Yeah.
then you also talked about data types, the unsigned and unsigned integers. I think you said in the the unsigned integer you can have like minus 10 or something. Then you spoke about
No.
function being reusable code.
For signed integers, you can have the negative. For unsigned integers, only the positive. So for continue, I appreciate hearing this.
Okay. Then you spoke about function being a reusable code. So I think function also helps us to keep a dry format, dry programming format. Yes, that's what I can remember.
Thank you so much. Thank you so much. Thank you, Stephanie. Thank you, IG. Benjamin, is there any other thing you want to add to it? Then we can proceed with today's class.
Looks like they've basically said it all. Yeah. So I would like to just but say something about the mutability, which I remember you making a statement that once you assign a value to a variable, right, you cannot change it unless you explicitly say like use the mute what is it, the mute function or something like that. Yeah. And then I think you also used an example where you wrote a bad code and then you sort of um, wrote a good code like by reducing the number of lines and stuff like that. Yeah. So basically that is
Excellent.
what I
Excellent. 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 I love that. I love that. I love that you all actually picked everything we discussed. Thank you so much. Thank you so much for this. So I feel Tosin, Benjamin, Stephen has basically given us all the revision we need, and there's really no need for me to do any revision anymore. So with having that in mind, I will just go straight to what we have for today. But something tells me to ask this question before going straight to what we have today. Is there anyone with any question based on what we have discussed from the last session? Any question? You can just use the raise hand button. So we are sure that no one is left behind. Any question? Okay. At the absence of no question, Otosin, are you raising your hand?
No, it was a mistake, sorry.
Okay. So at the absence of any question, we'll be moving on to something interesting today. Ownership and borrowing. What exactly is ownership and borrowing? Sorry, let me take water. Ownership is a situation whereby each value basically has a single owner. So what am I trying to say? What I'm trying to say is that for every single value that is declared to a variable in Rust, each of that value has just one single owner. And so whenever you reassign that value to another variable, the value is then moved to the new variable. So this means that for every single variable that you are creating, that value, now this concept is different from so many programming languages because it's basically Rust majorly that has this concept. Unless I've not seen any language that has this concept for now, although they might be, but it's basically Rust. So each value has its own owner in the sense that all the values are stored in memory, right? Now, for every single value that is stored in memory, each of them has just one owner. So that means that if you move a value into another variable, remember, a variable is just like a container holding a value. So if you move the variable inside a value, if you move a value inside another variable, that initial variable that has the value no longer have access to it. And so if you try to call that particular variable, it gives you a compiler error. But then, what then can you do when you are trying to use the same value in multiple places? In that case, you have to do what we call borrowing. Borrowing is a situation whereby you reference to a value in memory that is owned by another variable. So that new variable that is trying to reference, in that case, that variable now is only a reference to that value. It is not the owner of the value. So this means that that value is moved to another variable. Any variable referencing that initial value loses its what? Its access to the variable. What am I trying to say? Let's go to code. Let's go and demonstrate it in the code. Now let's comment out all of this. Let's comment it out. And let's come down here and talk about ownership and what? And referencing. What are we trying to say? Now we want to declare a value. Let's call the value value 1. Now for value 1, we made mention that value 1 is a string. Let's declare it as a string. And now, I kind of like my name, so I'm just going to use Ayo. Ayo is the name. Oh, sorry, string from. I physically used new. Forgive me. So Ayo is the name. Ayo is the value. Ayo is what? Ayo is the value. Now this value is owned by this variable 1. So that is, this value is stored inside variable 1, which I named value 1. In fact, let's name it variable 1. Let's not use value, variable 1. Let's name it variable 1, so it's easy. So it's inside variable 1. Now, what we are trying to say is that the moment we declare another variable, let's call it variable 2. Let's also make it a string. And then we said variable 2 is equal to variable 1. At this particular point, variable 1 has moved its value into what? Into variable 2. So that means that whatever we are doing in this life, we no longer have access to what? To variable 1. How do we know this? Let's just quickly try to print variable 1 and let's see what happens. Variable 1. Variable 1 is Can we see? We have a compiler error. Why do we have a compiler error? We have a compiler error because at this particular line of code, line 24, the value Ayo has been moved to variable 2. This is the concept of ownership. So now variable 2 is now the new owner of the value Ayo. In this sense, variable 1 no longer have access to Ayo in the memory. So this is the whole idea of ownership. Now let's go. Let's continue. Now in a case whereby we don't want to move the value Ayo to variable 2, but then we still want to be able to access Ayo. We want to be able to access Ayo through variable 1 and variable 2. We want to create another variable where we can consume Ayo without having to move the value Ayo into variable 2. That is where the second idea comes in, which is called referencing. And in a simple word, you can think of it as what? As borrowing. How do you do it? In this point, you use this to borrow. Now, at this particular point, you have a compiler error. Why do we have a compiler error? Simply because we are declaring it as a borrowed string. And now, This place, it is not a borrowed string. So you have to add it here too to show that now it is now a borrowed string. So this shows that this particular variable is not the owner of Ayo. All it is doing is that it is pointing to Ayo. That is pointing to variable 1. So it's pointing to the memory location on variable 1 where the value Ayo is, and it's only trying to borrow it for the time being. So now if you uncomment this, we no longer have a compiler issue. Why? In this particular case, variable 1 still owns the value Ayo. So variable 2 in this sense is now borrowing what? Is now borrowing Ayo. Is there any question from this? Please raise your hand if you have any question, please. Let me see if every single person understands this. Any question? Okay, Benjamin, please. Bring Benjamin and Alan to the stage.
Okay. It's if I got your explanation between the ownership and the borrowing right. So meaning it is more like um, how should I even put it? So it is more like if let me say you give your phone out, right? So this is in regards to the ownership. If you give your phone out to somebody, right? And then um what that's the person, like when you give your phone out to somebody, right? And then meaning you don't have like ownership of your phone, right? But then the borrowing um is more like if you give your phone to your friend or somebody and you go like, okay, they should handle it for some time, or like they should um, play with it for some time, but then they must return it, right? If I'm getting it right. So meaning the borrowing can also be referred to as mutable borrowing, if I'm right.
No, no. Now, we have not gotten to that particular point. Now, we have what we call, your question, if I'm to very clear about it, is that, are we saying that we have mutated variable 2 because the value has been moved? The answer is no. But then there's another concept which we'll be moving to, which we will call mutable referencing, or you can think of it as mutable borrowing. But we have not gotten to that point. But I want you to know that it's just like you having your bucket and someone having his own bucket. Now, you can either pour the water inside that person's bucket, inside your bucket, or you can borrow that person's bucket with the water. That is the idea between moving the ownership. The moment you pour that water inside your bucket, you are now the owner of that water. But then, if you borrow the bucket with the water from the person, you are not the owner of the water, but you are still having access to that water because you did what? You borrowed it. Now, if you pour the water into your bucket, the original owner no longer have access to it. The original owner can only do something. It can only what? It can only borrow now from you, since you are the new owner of the water. So you can think of it like that, basically. So let's hear from you, Alan. Alan, please, you can unmute.
Okay, so hi Ayo, can you hear me?
Yeah, I can hear you.
Okay, so I just wanted to confirm whether I'm getting it right about the borrowing, the ownership and the borrowing. So like, is it like when a value is passed into a function, or maybe it's moved to another variable, the ownership of that value is transferred?
Exactly. The ownership of that value is transferred. The owner becomes the new variable that it was moved to. Exactly. Now that you talk about it, I know I've not gotten there, but we are still
Okay.
going to talk
So
about
this means that the original variable can't be used afterwards.
exactly.
Okay. Thank you.
Basically that. Yeah. Now let's continue. Now, we have spoken about ownership and referencing. Now, is there a situation whereby we can change what is here without having to what? To change it from here. What do I mean by that? That is where we have something called mutable variable. What do we mean by this? Now, technically, let me go back to what we had before. Technically, variable 2 at this point is now referencing variable 1. We could come down here and say, variable 2 is equal to, let's now change the string from, I want us to see what will happen. This time, let's use below. We have a problem. Why do we have a problem? I mean, the normal problem we would have here would definitely be that this one is not mutable, right? It's not mutable. Another problem is that it is a borrowed string. So if we add this here and say, okay, fine, we said it's a borrowed string. We have this here. It's still a problem. Why? Because we didn't add mute keywords to this, right? Yes. Now, if you add mute keywords to this, now this at this particular point becomes mutable, and that is the original value of this one is now gone. So it no longer holds variable 1. Instead, it has a new variable. It's no longer referencing variable 1. Instead, it's referencing a new value, the new value which is below. But then, what if we are trying to change variable 1 from variable 2? Is it even possible? Remember, at this particular point, variable 1 is still the owner of the value IO. But is it possible for us to change the value IO through variable 2 since we are referencing it? That is where mutable reference come into place. Now, for us to reference and mutate variable 1, obviously, variable 1 has to be a mutable variable, right? Now, let me remove this and let's see. Now, variable 1 has to be a mutable variable. But then, we add the mute keyword in front of line 24. So at this particular point, we have made this, let me remove this. We have made this a mutable reference. So that means that whatever is in variable 1, it is now possible for us to mutate the value of variable 1 through variable 2. What am I trying to say? What I'm trying to say now is, if we say variable 2 is equal to string from, let's use below that we used before. It's possible. Let's add the mute keyword here. Oh, we didn't add this. Oh, let me remove. Oh. Yes. Now, what does this mean? This means that it will mutate the value of variable 1. By mutating the value of variable 1, let's cargo run it and let's see. So at this particular point, it did not mutate value of variable 1, rather it mutated its own variable, right? Why? Let's see. Now this is this. Oh, sorry. I didn't change this one to this. I didn't change this one to this. Okay. Borrow letter used. Good, good, good. Oh, we didn't change it here. Value assigned to variable one is never read. Yes, maybe it's overridden. Okay, let's try to print it here to use it. Yeah, variable one is this. Let's add first variable one is this, and then we add variable one here. So we still have a problem. Okay, here's the problem. Can't borrow variable one as, oh, sorry. This one is still going to be a problem because it has been consumed here. So let's do this and see. Okay, so now let's change this and say variable one is equal to this. What happens? We still have a problem. Why? This is because variable one is already borrowed. And now variable one that is borrowed is not yet what consumed. So variable two is borrowing variable one, and now we are now trying to mutate variable one. So it's going to give us a compiler error. Why? Because variable one is still being borrowed and it has not been consumed. So what's the benefit of all these things we are trying to show in Rust with the compiler error? The benefit of all of these things is all about the memory management. With this, it is possible for you to manage your memory. You are forced to manage your memory. So you don't have allocations of memory that is not being used, that is running on your computer. So imagine you build an application, and then this application, due to the fact that you use the programming language that just keeps allocating memories without the use of these memories, because the value is eventually transferred and moved somewhere else. And you are not strictly held to look at the value and variable that is being moved. In this particular case, you would have a problem. And that is exactly why Rust is called a very fast programming language, because all of this memory is managed well. Now let's go to another concept. I'm going to remove this. What if we have something new? We have variable 3. Now, we said variable 3. We want to say variable 3 is borrowing variable 2. What then happens? At this particular point, we could say variable 3 is a reference of a reference to variable 1. Why? This is because variable 2 is referencing variable 1. And at this particular point, we notice that we now have 2 of these reference signs in front of what? Of the data type. That is because variable 1 is being referenced twice by variable 3, because it is going through a reference of a reference of a reference. So is there a way for us to reduce this referencing? It's possible. That particular concept is called dereferencing. How do you do this? Let's create variable 4. At this particular point, we are now going to use this sign star, and then we are going to what? Variable 3. What did we notice? We notice that now the data type for this is being referenced just once. Why is it referenced just once? That is because we have dereferenced it. We have dereferenced it, and it no longer have access to what? It no longer have access to this variable as a double reference. Rather, it is referencing variable 2 directly. Does anyone have any question based on that? Or do I proceed? Anyone have any question? Yes, you can unmute, please.
Yeah, my question is what you said about referencing and re-referencing. Can you repeat it again? I didn't get that.
Okay, great. What of Stephanie? What's your question?
So instead of double referencing, we can just reference.
Yes. Now there's a situation whereby the data type, remember, let me say something. Well, this is going to explain this over again. Whenever you create a data type, let's variable 5. Let's name this one variable 5. Let's say it is now string, and then we are referencing variable 2. Imagine we are referencing variable 2. Or no, let's say we are referencing variable 3. Okay. At this particular point, if I'm to remove this, we notice that we have a reference of a reference of a reference of a reference of the string. There are situations whereby we might not want to have a reference of a reference of a reference because we want to have a data type that is compatible with what we are doing. At that particular case, we then have to do what? We then have to dereference. So dereferencing will just remove the references. It's just like I borrowed this eraser from Tunde. Tunde is the major owner of the eraser. I borrowed it from Tunde. Then Stephanie borrowed the eraser from me. Then who again do we have here? Benjamin borrowed the eraser from the next person from Stephanie. So the borrowing keeps on going and going and going like that. And then it will now be that the whole chain of borrowing can then be broken down by dereferencing. So if you keep dereferencing, you will then have the means to the original owner. So that's all about the referencing. Now let's go back to explaining what referencing and dereferencing is, as Miracle asked. So for dereferencing and referencing, like I made mention of, it's a borrow of a borrow of a borrow. This borrowed from this borrowed from this, and so it became a double borrow. But then at this particular point, this does not want to borrow from this person directly. What did he now do? He now dereferenced the borrowing. He now took the eraser. You can now think of it that now let's in fact let's make it practical. Let's make it practical. Let's say Bello is the owner of the eraser. So Ayo borrowed it from Bello. Now at this particular point, Miracle, he borrowed it from Ayo, and then someone else borrowed it from Miracle. Let's say Paul borrowed it from Miracle. Now, at this particular point, the next person on the list does not want to borrow directly from Paul. So what did he do? He now said, instead, I'm going to borrow from Miracle, but I'm going to tell Paul that I'm telling Miracle that I have borrowed this eraser. So at that particular point, this next person, let's choose someone's name. Let's say IJ. Now, at this particular point, IJ then told Paul that no, I'm not borrowing this thing from you. Rather, I want to borrow it from Miracle. So IJ came to Miracle, and then he told Miracle that yes, I've borrowed the pen, the razor from Paul. The razor is now with me. Now remember that at this particular point, Miracle is the second person that borrowed from Ayo, but Miracle is not the original owner. That is why this is still what? This is still a reference. So that is why, even though IJ has already dereferenced Paul and he has gone directly to Miracle to borrow, it does not mean that he is still not borrowing from a borrower. It's just that he has removed one of the chain in the borrowing line for him to borrow directly from Miracle. So the borrowing reference is then cut short. That is all what the referencing looks like. I hope that is
Okay.
gotten.
So just to clarify, right? So in the case of variable one, variable two, variable three, and variable three, and variable four, sorry. So now variable four, the reference variable three. So like you borrow
Ah,
directly from variable three, right?
exactly. Exactly. So what is here is literally saying it is what is here. Literally.
But it's variable three that is being called on line 26.
Yes. So it is just like IJ telling Miracle that I have borrowed the razor from Paul. But then when
Mm,
you called variable 3, it
mm,
dereferenced it, it moved it.
okay. So directly now, variable four is borrowing from variable two.
2.
Okay.
Exactly.
Okay.
Exactly. So that's just the whole idea behind it. Now,
Okay.
the whole idea of this borrowing, it will come into place when you start building applications where you need a particular variable to be used and consumed in different places. Now, when we talk about ownership and borrowing and referencing, another thing you have to think of is a function. The moment you pass in a variable to a function, the function automatically becomes the owner of that variable, unless the parameters passed in is a reference. What am I trying to say? Let's quickly create a function. Let's create a function. Oh, did I write function out? Forgive me. Let's create a function print. Print name. Let's call it print name. Now, this function is taking just something in. It's taking string in. What's the string it's taking in? The name. So we are going to make it the string, and it's not returning anything. The only thing it is doing is it's printing a name. Then let's call the print macro, and inside of it we say my name is this, and then you can have the name written there. Now let's declare a variable named my name. Now my name is actually a string, and this time I won't use Ayo, I'll use the full one, Ayomide. So now I am now calling my function print name. Now my function print name is taking in my name. Now, my function print name, this function has taken in this variable. What happens if I try to reuse that variable? Let's say I'm trying to say let um, name2 equals my name. We have a compiler error. Or let's even say this time we are not even doing anything. We want to borrow. What happens? We still have a compiler error. Why do we have a compiler error? We have a compiler error because this particular function has taken up the ownership of whatever variable is coming in to this parameter. And at that particular point, this my name is then consumed by this function. So in that case, what do we do if we don't want this function to consume it? All we have to do is what? Add mutable. And if you add mutable to it, we also have to add it here. And then everyone goes on happy. At this particular point, this my name is not consumed anymore. Rather, my name is then what? Is then passed in as a reference to this function, print name. Did you get that, Benjamin? Okay. I guess it's no longer up on the stage. So that's basically it. We'll be moving on to another concept. Enums.
Yeah, I actually did get that. Yeah, thank you for the clarity.
Okay, great. I just want to be clear on something. While we were talking about data types, did we talk
I
about...
think Stephanie has a question.
Oh, Stephanie, please, let's hear from you.
And can you please go back to your VS Code? I want to ask one. Okay, you said something that, like my name now, you said it's being referenced, not consumed. So are you trying to say if you remove that reference sign, means it is consumed, and means you cannot reference it again in my name too?
Yes, that's what I'm trying to say. Now, we are this for every function that you create. If you pass in this dynamic types data type string in our case into it, at this particular point, whatever is coming in here is owned by this function. That is because we didn't add the what? The reference. So at this particular point, we have passed in my name here. And so if we try to use it any other place, we no longer have access to it because the ownership has been moved to this function. Look, how do we know? This is one way of trying to use my name again, right? This is another way of how to use it. Let's just try to print it out. Name. And put my name. We have a problem. Can you see the problem? Borrow of moved value. Value borrowed after move. So you are trying to borrow something that has been moved. Trying to use water that has become someone else's own. Someone else has claimed the ownership. Okay. Someone is saying something. Okay. So you're trying to use something that has been moved, that the ownership has been moved to someone else. So that is basically what is happening here. So you can no longer use this variable after line 32. But let's try something. Having this in mind, Stephanie, let me pick up your mind. Let me try to see if what we have been discussing, you actually got it. What if before I consumed it by this function, I tried to do something? I tried to say, let name equals name2 equals, and I tried to borrow my name, right? What would happen if I print name2? If I change this line 36 and I uncomment it and I put name2 here, let me if I do it before I uncomment it. What would happen? Stephanie, can you answer that question? On line 36, remember that this is referencing my name. But on line 34, this print name function has consumed and used up my name. So what happens to this particular name2 that is trying to reference something that has been consumed? Will it, it's referencing it. There's no problem on this line, as you can see. The compiler is not having any issue. What then happens if I uncomment line 36? Can you answer that, Stephanie? You can unmute and speak, please. Hello?
So I think there won't be a problem since, There will be a problem. There will be a problem. It will throw
Why
a
would there be a
compiler
problem?
because
Why
what
would
you're
there be?
referencing, what name two is referencing name one, and name one is name. My name is already consumed, so there's nothing for name two to reference again, to print out again. That's why it will be a problem.
Now, but name two is already referencing it and he had stored it in the variable here. So why should it not be able to print it?
Because we already used the problem, we have already used the value already in line 34. Oh,
And the problem? Are you wrong or you are right?
I'm wrong.
So why do you think we have this error? Apart from Stephanie, any other person can raise the hand and answer the question. But Stephanie, why do you think we have this problem now?
I think it's because we referenced my name, then the value was already moved to name two. So I don't think
But
it's the value
the
is
value
changed.
moved to name two, or was it borrowed?
It was borrowed
So why is there now a problem when I'm trying to, the original owner is trying to use it? Why do we now have a problem?
because we didn't put reference at name one.
Really?
Yes, I think if you
Name one.
put reference
You want me to
in
put
my
reference?
name,
Yeah. Do you want me to put
yes,
reference? Yeah. Okay, I'm going
yes.
to put reference. I'm going to put reference. Now I've added reference. We are still having a problem. But I just want to point it out to you that this particular would not even work with reference because there's a problem here. If the data type is not a reference, you would have a problem. Now, if I added reference here, then the whole matter changes. But no, we are not adding reference. It is not a reference. So the referencing is not even the issue here. Does anybody else want to try? Okay, yeah, we have
Yes,
raised
yes, I
up.
would love to
No,
try.
Miracle. Let's hear from Mo. I don't think I've heard Mo's voice.
So
Let's hear
I
from Mo.
feel that the reason why we're having that error is because the value of the name one has been moved to name two. And so name one is now like invalid. It no longer exists. So
But
that's why we're having the error.
let me ask you, Miracle. At this particular point, this is a reference. It's not a move. Assuming we remove this reference in front of line 32, then we know that it is a move. But this is not a move, it's a reference. And we said that when a variable is referencing a value, at that particular point, the value is still owned by the original owner. So that's not the answer. So let's hear from someone else, Mo.
Good afternoon, sir. I don't really have an answer. It's a question I wanted to ask. Can I go ahead, or should I wait later?
Go ahead, go ahead, go ahead.
Okay, my question was, it seems does the reference like remove the value entirely from the initial holder or like the data type that was holding the data initially? Does it remove it or just like it makes reference to the value?
The answer to your question is that it doesn't remove it. It only make a reference to it. Um, you know what? Give me a second. Let me do something. Can everyone see my screen? Hello?
Yes, you
Yes.
can see your screen.
You can see white, right?
Yes, yes,
Okay.
yes.
Now, I'm going to demonstrate it um, by using my hand to draw it. Now, this is value 1. This is the value 1, right? Value 1 is owned by variable 1. Now, anything that makes, this is variable 2. We declared it. Variable 2. The moment variable 2 is borrowing from value 1, all it is doing is it is creating a pointer to value 1 in the memory. Now, you can think of this circle as memory. So it is only creating a pointer to it in the memory. But then, the moment a second scenario happens where variable 1 has value 1 in memory, the moment variable 2 is the owner of this value, it will no longer point to this directly. Instead, it will point to value 1. And so it will not be a reference, rather it will be the owner. And at this particular point, variable 1 no longer have access to value 1. So the difference between it is that variable 2 have access to value 1 without being the original owner. But then, this is for borrowing. But then, for referencing, it is basically the same thing as borrowing. But then, for movement of ownership, the moment variable 2 is equal to variable 1, the value is no longer owned by what? By variable 1. The value has been moved to variable 2. In this point, variable 2 is the new owner of the value. And that actually leads us to our question. What is that question? Why is this throwing error? The simple reason why it is throwing error is this. I'm going to give us all an illustration we can relate with. I bought a phone. I bought my phone and I'm enjoying my phone. But then Mo came to me and Mo was like, can I borrow your phone for my exam? Or in fact, let's use the laptop. I have a laptop. And then Mo came to me and is like, can I borrow your laptop for an exam I want to do? The exam is going to take 2 days. At the very moment Mo borrows that laptop, as the owner of the laptop, do I have access to that laptop at that particular time to use it up? The answer to that is no. The fact that I borrowed the laptop to Mo does not mean I can sell that laptop at that point, or I can move the ownership of that laptop at that point to someone else. Why? This is because the laptop is not with me. Rather, it is with Mo. And Mo at that time is borrowing it, but Mo is not the owner of the laptop. So we can use that to explain what is going on here. At this particular time, whenever you reference a particular value from a variable, the value that is being referenced, the owner of the value cannot consume it or move it into another variable, because this one is still borrowing it. It's just a simple idea of borrowing and owning something. It cannot move it because this one is still borrowing it. And so that is what is happening here. But let's try something else. Let's try this. What then happens? At this particular point, name 2 has been consumed. So name 2 has been consumed, which means the ownership, the full ownership of that variable or of that value is now back to my name, which is, let's leave it as my name. It is now back to my name. And at that particular point, my name can now use the full ownership and I can transfer the whole ownership to someone else. Does this make sense to us? Now, I'm very sure that this particular concept is part of what makes people think Rust is a very steep language to learn. I mean, we are trying to just pass in variable, and we are having so many complicated issues. I don't know whether I should pass in my variable to this one before I borrow it to this one, or before I reference it. When exactly should I reference it? When exactly should I borrow? Or why don't I just move my value completely? All of these particular rules are what allows Rust to be efficient. In that every single value, every single data in the memory is being accounted for. Every single data in the memory, we know where the data is at that particular time. We know who is using that data. We know where a memory is being used. We don't just create different memories and waste all of these memories by declaring different values. So because in other programming languages, like for example, Python or JavaScript, you can declare a value and keep passing that value to another variable on and on and on to infinity if you like. But then, what does that cause? That causes allocation of value to memories that are not being used. And this, in effect, make your application what? Slower. That is because, and that's exactly why certain applications, unless you are a seasoned developer that you are intentionally knowing that, okay, I'm not declaring this variable because I don't need it here. And if I want to declare it, I'm declaring it for this reason. Then you know you are the one intentionally optimizing your code to make your application or your software that you are creating faster. And that's just what differentiates Rust with so many languages. Memory management. Memory is allocated rightly without being used anyhow. Do we get that? Do we get that?
Yes.
Great, 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 great. Okay, so let's proceed. I know our time is up, but I want us to talk about, I want to ask a question. While we were talking about data types, I know we extensively spoke about integers, floats, booleans, and character data type. But did we talk about the compound data types? Did we talk
No,
about
we didn't.
what?
No, we didn't. No,
We
we
did.
didn't.
Okay. So at the course of this class, we are going to talk about it now. So we're going to talk about it now, and that would be the end of our lecture for today. So compound data type. Why are we talking about compound data type now? That's because the next thing we are meant to talk about is enums and structs. And now these are also custom data types. And now it's not wise for we to know custom data type when we don't even know about compound data types. So it's important that we talk about it. So compound data type. For compound data type, let's go back. Okay, let's comment out all of this and all of this and all of this. So let's talk about compound data type. Now for compound data type, just like the name denotes, compounding. That is, you are having more than one. Now, looking at our previous data types that we had here, we had just one single data type here. This is an integer, this is a uint, this is a boolean, a char, a character, a floating point, a string slice. Like all of those are basically single characters. Is it possible for us to combine these single characters together to create a compound data type? The answer to that is yes. And today we'll be talking about two compound data types. The first one is tuples. And the second one we'll be talking about is arrays. Now, when we talk about arrays, for today's class, I'm also going to talk about something. vector. Now, we are going to talk about tuples, arrays, and vectors. Now, these two are the major compound data type that we are going to talk about because they are fixed size data type. Even though they are compound data type, they are fixed size. But then for something like vectors, vectors is not a fixed data type. Rather, it's a dynamically sized data type. But we are going to talk about it. We are going to understand the difference between a fixed data type and a dynamically sized data type. So let's start with tuples. How do we declare a tuple? Let's name this tuple 1. Don't mind my naming conventions. It's because we are not building something right now. That's why I'm naming it like this. So for tuple 1, what is the beautiful thing about a tuple? In a tuple, you can have different data type combined together. What do I mean by this? You can have 23, you can have true, you can have hello. In fact, let's add other data types. You can have a character, you can have a floating point. Can you see? Uh, I'm trying to see why this is showing red. Okay. Okay, so we are good. So can we see? This is a compound data type. Why is it a compound data type? It's a compound data type because you can basically have so many different data types combined together. Why? This is because we could want to build something whereby we could want to build probably a function and we need to return a compound data type in that we are not returning just one value. We are returning multiple values, and these multiple values are basically not the same data type. In this case, you could use a tuple. So now, how do you have access to all of these tuples? You have access to all of these tuples by saying tuple. You can destructure it. There are two ways to destructure it. I'll show you. The first one is you can destructure it by having access to each of these elements. Now, each of these elements you can think of it like elements starting from index 0. So you can access this first tuple by saying tuple 1.0. So with this, we have access to the first one, which is an I32 integer. Then we could say let tuple boolean be equals what? Tuple 1.1. And on and on and on and on and on like that. You could keep having it to destructure them like this. So at this particular point with this, you can have access to all of the single elements in the tuple. But what happens if we try to get, let's name this one none. Let's say we try to get a particular element that is not part of the tuple. Let's say 0.5. What do we have? We would have a compiler error. Why? This is because 5 is not part of this element. We have index 0, index 1, index 2, index 3, index 4. Now, index 5 is not part of it, and so for that reason, Rust will immediately tell us, hello, you have a compiler issue, that tuple 5 is not part of it. Now, you could extend this and have probably something else, and then at that particular point, definitely tuple 5 would be part of it because At that point, we've added one more element to it. So that is that about tuples. But I meant mention that we can destructure it in a different way. How could we destructure this again? Now let's comment all of this out. The next way we'll say to destructure it, you create a tuple in itself, and then you'd say tuple, could name it whatever you want to name it. I'm naming this tuple I32 tuple Boolean, and on and on and on like that. So at this, I named it tuple I32 tuple Boolean, tuple string, tuple char, tuple float, tuple none. And with this, I equaled it to the tuple one, which is the main tuple. And that I can basically come ahead to print what I have here. So I can basically print, and when I print, I could have whatever do I want to print. I could print, let's say, tuple string. I want to print tuple string slice. That's a string slice. So let me try to print it. Print this is string slice, and yeah, then I have this, and I just put tuple string slice. And so if I cargo run, I'm going to have what? This is string slice hello. So that's basically how to destructure this tuple, basically. So now, that is that on tuples. Let's move on to the next compound data types, array. Now, for those that are coming from other programming languages, array is probably not a new idea for so many. This is because everyone that has probably been coding before understands that array is basically a bunch of data types inside of a square bracket, and then it is identified by each element. Well, one thing that differentiates Rust from other languages also, especially languages that are not typed language, is that even for an array, every single element in that array is accounted for. For example, let's create this array. Let's name it array1. Now, array1 is inside a square bracket, and it has 1, 2, 3, 4, 5 elements inside of it. At this particular point, array1 has the I32 elements inside of it. And so in front of array1, we declared that it is an I32 with 5 elements inside of it. This is why we said it's a fixed data type. So in the memory, it is known that this particular array cannot increase. So you cannot use all those methods like .push, .pop, and all of those array method that you think from other programming languages here. You can't use it on an array here because this array is a fixed sized array. Let's try to do something. Let's try to add another number to it. Let's try to add 6. Can you see? We have a compiler error. Why do we have a compiler error? This is because we specifically defined it here that this array is an array with length of 5 elements. And we are trying to make it an array with length of 6. And the compiler is like, are you kidding me? You told me it's 5 elements. Why are you packing in 6 elements there? You told me you want to allocate 5 element space in the memory. Why are you putting 6 there? So you either have to convert these changes to 6 or you have to remove the 6. What happens also in a case where you are trying to make an array size higher than what you are passing in? It still complains to you, hello, you have to be exact, make your decisions. You have to be sure that what you are saying is what you are doing. In this case, what you do is that the exact amount of array element you are passing in must be what? Must be the same. Can you see why Rust is a very strict language? And that's also why everything is going well. It's just like thinking of a country that has strict regulations. That country would do well because every single thing is regulated and the country would enjoy certain benefits. When there will be low crime rates, economic crimes will be declined, and all of those kind of things. You can think of Rust in the same way. There are so many rules that binds it, and that's exactly why it's a very, very fast language. Now let's make another mistake intentionally. Let's change this one to a U32. What happens? No problem. Why? Because 1, 2, 3, 4, 5, 6 is also an unsigned integer. But what happens when we try to add -4 here? We have a problem. Why? -4 is not an unsigned integer. We want to remember that unsigned integers start from what? They basically start from 0. So 0 to the maximum of that bits of the unsigned integer. In this case, it is 32 bits. So -4 is not part of it. So it's going to throw a compiler error and tell you, hello, why are you trying to add what is not meant to be there? So the data type you're adding here must be the exact data type for all the elements that are available in this array. So for us to make this fair, we have to convert it back to I32. If you convert it back to I32, there's no problem because -4 is also in the range of what? Of I32. So for this, you have to specify the amount of elements in the array, and then you also have to specify what? The data type for all the elements. So all the elements in the array have to have the same exact data type. This is a compound data type, but it is a fixed compound data type. At this point, do we have any question? Any question? Yeah, two please.
Okay, my question is, you made mention that unlike every other programming language that we are used to, that it is impossible for us to use those pop method, what's it called, append method in such a way here. So does that mean that whenever we want to declare an array here, we would always have the understanding of the total amount of space that is needed, like in real life scenario now? I don't know if you get my question.
I get your question. And that is what leads us to the next thing we are going to talk about.
Okay.
Vector.
Okay.
Now, we made mention that arrays definitely have a fixed length. I mean, what if you are creating a function and the function is telling us that we want to keep adding new students to a particular class? Does that mean that we would have to create a way whereby we'd have to keep updating the data type of and trying to update how many elements should be in it? The answer to that is no. Why? This introduces us to the next thing we'll be talking about, vectors. Now, you can think of vectors as arrays that have unlimited size. In this case, we call vectors dynamically sized variable. Why do we call it dynamically sized variable? It's because the vector, now when we are talking about memories and variables in memories, we now start thinking of what we call the heap. Now, what I'm talking about is now going to the low-level part of computer science. Now, the vectors are stored in the heap. And when the vectors are stored in the heap literally is used for dynamically sized variables, for variables that you don't know their exact size. Rather, what you would then have is a pointer, like a mapping to that particular variable. What do we mean by this? To declare a vector, all you have to do, let's name this one vector 1. Vector 1. Let's say vector 1 is equal to vec Now, let's say we want to do the same thing we had there. 1, 2, 3, 4, 5, 6. So now, in this particular case, notice that we now have 1, 2, 3, 4, 5, 6. So this particular data type is completely different from this data type. Instead, this particular data type, we define the data type by using vec and then adding the data type, the exact data type inside of it. So this is just trying to imitate this. Now, this one is the one where we can now add new numbers by saying vector.push. And then what are we trying to push inside of it? We can try to push 7. Now, we are having a compiler error. Can anybody tell me why we are having this compiler error based on what we have learned from this class? Anybody, please?
Currently, it is unmutable.
Thank you very much. That's just the correct answer. It is what? Unmutable. And we have to make it mutable. So that mutable and unmutable basically applies to all data types. So in this case, you can see that you can now use this particular method to add a new element to this. So this is what represents the normal vectors you know, the normal arrays you know in other programming languages like JavaScript. You get. Now, thinking about it, how then do we declare a new vector? I mean, this particular vector, we started it by, creating this. How do we declare a new vector? We can say, let's name it new vec. And for this new vector, we declare it by saying vec new. And just like that, we declare the vector. But there's always a problem when you declare a new vector. Why is this thing giving us a compiler error? It's giving us a compiler error because, first of all, this particular new vec, we need to know the data type. So the fact that it's a dynamically sized data type does not mean every single element of it can be scattered. It means that it has to have a definite data type. What do I mean by definite data type? If we go back to this one and we add 0.8 there, we are going to have an error, a compiler error. Why? This particular vec is an I32 vector. So it's not a floating point. And in that case, you cannot add a floating point to the vector. So that means that even if it's dynamically sized, it also has to maintain the same data type. And in that particular case, that leads us to what we have here. It leads us to understanding that we have to define the exact data type we are passing in. For this one, I could decide that what I want to pass in is Boolean. So in that case, if I come here and I say new vec, and I say dot push, and I add 45. Now, let me quickly add the mute here. And I add 45. We would have a problem. Why? This only requires a Boolean because we have declared a Boolean to be what we are doing what? We are passing in to this vector. So it's a typed language. Every single thing has to be accounted for. You cannot make a mistake. You cannot miss. And that's exactly why it's a beautiful language. It's a very, very beautiful language. So this is where we'll be stopping our class for today. Are there any questions generally from everything we have learned in today's class? Any questions? I'll stop sharing my screen now. You can raise your hands if you have any questions. Okay, in the absence of questions, I would believe that every single one of us have consumed what we have learned today. Now, here's the beautiful thing about it. If you keep learning this and you are not implementing it immediately after the class, you would have a problem. What's that problem? That's because the language is a little different from other languages in that you have to practice. In fact, for other languages, you also have to practice. So that means that as you are learning it, you have to practice it because the time frame, to be very honest, to learn this language is lower than what we have. And so for you to have maximum benefit from what we are learning, you have to immediately practice every single thing that we are learning. Naturally, I know I'm meant to have stopped about 25 minutes ago, but because we have not even covered the slide we are meant to do today, I had to use this extra time to cover this. So on your own time too, you basically have to go extra miles to redo every single thing we had in class today. And trust me, as you're implementing it, you would have problems. It's the truth. The class is an opportunity for us to solve those problems and for you to grow. At this point, I'll be passing the mic on to IJ to end the session for today. So thank you very much, everyone, for coming.
Hi, everyone. Thank you for coming. It's been great. Let me stop the recording first.